For today's lesson, we will be discussing about the basic concepts of hypothesis testing. So first, let's define what is hypothesis. So hypothesis, it is a tentative statement or explanation of a phenomenon. It is a conjecture or assertion about a parameter. So an example of a hypothesis is, let's say, when you drink coffee, you cannot, or it will be hard for you to sleep at night. So that is an example of a hypothesis. Or another one is, let's say, if you get at least 6 hours of sleep, you will do better on tests than if you get less sleep. So those are just example of hypotheses. You are trying to give a tentative statement. Okay? And in statistics, we have what we call a statistical hypothesis. So it is a statement about the numerical value of a population parameter. So of course, when we are doing some experiments or study, so of course we have the population, and then from that population you can identify the different parameters or values, and we can create statements regarding that parameter, and we call it as our statistical hypothesis. It can also be referred as a prediction regarding the possible outcome of a study. So what will be the possible outcome of your study? So that also refers to hypothesis. So it can be shown to be supported or not supported. So the reason why you are, of course, writing a research or a study is because you want to show if the hypothesis that you created is really true or not. And in order for us to check or to prove that our hypothesis is true or not, so we use hypothesis testing. So it is a statistical testing procedure where a hypothesis is being resolved whether it is true or not. So using the different ways or methods in hypothesis testing, we can make a conclusion if our hypothesis is true or not. So it's really important that you know first how to write your hypothesis, of course, before we can try to prove it. So that will be our focus for today. So we will have another set of video for the hypothesis testing itself. Now, there are two kinds of hypotheses. We have what we call as the null hypothesis and the alternative hypothesis. So what is null hypothesis? It states that a population parameter is equal to the hypothesized value. So one thing that we just have to remember for our null hypothesis is that we always state or assume that our population parameter is equal. So that's what we want. So we want to state or assume that our population parameter is equal to our hypothesized value. Or if you are comparing two populations, if you are comparing two means from different populations, you will always say that there's no difference between the two, or the two values are just equal with one another. So that is under null hypothesis, and we denote it using H sub O or HO. For our alternative hypothesis, it states that a population parameter is different. So you have here the word different than the hypothesized value. So here, it's like you're contradicting the null hypothesis, because in null hypothesis, we say or we state that the values are equal with one another. But for alternative hypothesis, we state that the values that we have are different from one another. So the population parameter is different from our hypothesized value. Or if you are comparing two values, we can say that they are different with one another. And we use H sub A or HA to write our alternative hypothesis. Now, there are two types of hypothesis testing, and it can be seen through our alternative hypothesis. So first is the one-tailed or directional, and we have the two-tailed or non-directional. So for one-tailed, if the alternative hypothesis is expressed using the greater than or less than symbols, then we can say that it is one-tailed. So the concept here is that we are comparing our population parameter with a hypothesized value, and we want to be specific with the difference of the two. Will it be greater than the hypothesized value, or will it be less than our hypothesized value? That's why it's one-tailed or directional. But for two-tailed, we only express our alternative hypothesis using the not equal to Okay, so here we don't mind if it's greater than or equal or greater than or less than our hypothesized value, but what we want to check is that if they're just different with one another or if it's not equal with our hypothesized value. Okay, so these are again the two types of hypothesis testing. So now what we will do is we will try to write the null hypothesis and the alternative hypothesis for each statement. So I will be showing you statements or claims, and then we just have to write the corresponding null and alternative hypothesis. So first, the average monthly income of Filipino families who belong to low income bracket is 9,000 pesos. So this is now the claim or the statement. To start writing your null hypothesis, so you just have to identify first what are you trying to identify from your population or what's your population parameter, and check is there a hypothesized value or are you comparing it to a certain value. So here, as you can see, we have or we want to compare the average monthly income of the Filipino families to a specific value, which is the 9,000 pesos. So the average monthly income, that will be the population parameter, or that's the one that we want to identify from our population, and we want to check if it is really 9,000 pesos. So 9,000 pesos is our hypothesized value. So for our null hypothesis, it should be the average monthly income of Filipino families who belong to low income bracket is 9,000 pesos. So here, again, we state for our null hypothesis that there is no difference, or the hypothesized value is just equal with our population parameter. So that's why we just write it as like this. In symbols, so the average monthly income, so that means if we want to get the mean monthly income of your population, should be equal with 9,000. So you can write it in symbol as like this. And that will be our null hypothesis. For our alternative hypothesis, so remember, in alternative hypothesis, we want to state that there is a difference between our population parameter and our hypothesized value. So what you will do is we just have to negate this one, or you just have to contradict the null hypothesis. So we can write our alternative hypothesis as like this. The average monthly income of Filipino families who belong to low income bracket is not equal to 9,000 pesos. Or you can just remove equal and you can just say is not 9,000 pesos. So the two are just the same. So in symbols, we can write this as the mean or the average monthly income is not the same or not equal with 9,000 pesos. So this is how we write our null hypothesis and alternative hypothesis. So remember, null hypothesis, we always assume that our population parameter and our hypothesized value are equal. And then for our alternative hypothesis, we assume that there is a difference between the two values. Another example, the average height of Filipinos is less than 162.56 centimeter. So in this problem, what we want to identify from our population is their average height. So here we have the average height, and there is a value stated which is 162.56 centimeter. So we can say that that is our hypothesized value. So to write our null hypothesis, so it should be like this. The average height of Filipinos is 162.56 because again, for null hypothesis, we assume that our population parameter is just the same as our hypothesized value. So there is no difference at all, or they are just equal with one another. So in symbols, we can write this as, so the average height or the mean height is just the same as 162.56. So that is for our null hypothesis. Now, for our alternative hypothesis, you just have to, again, contradict this one, but looking at our statement or the claim, you can see that there is the word less than. So we just have to use that for our alternative hypothesis. So it will be the average height of Filipinos is less than 162.56. So if you will write, this is symbol, so this will be less than 162.56. And since we already used the less than symbol, that means this one is already a one-tailed test. So our previous example a while ago, so that is two-tailed because we use the not equal symbol for our alternative hypotheses. Third example, a teacher wants to identify if there is a significant difference between the mean scores of students from Section A and Section B in a statistic test. So here, again, you just have to identify what are the things that you're trying to compare, or what are the values that we want to compare with one another. So if you will read the problem, it was stated that the teacher wants to identify if there's a significant difference between the mean scores of students from Section A and Section B. That means the teacher is comparing now the mean score of students from A and students from B. So to write our null hypothesis, since again for our null hypothesis we say that the values should be equal, or the one that we are comparing should be equal. So what we will write here is there is no significant difference between the mean scores of students from Section A and Section B in a statistic test. So here we are stating that there is no significant difference between the scores of the two sections. That means they are just somehow equal with one another. So in symbol, we can write this as the mean of the students from A is just the same as the mean of the students from B. Okay? And then for our alternative hypothesis, since again in our alternative hypothesis, we want to state that there's a difference between the values that we are comparing. So it should be, there is a significant difference between the mean scores of students from Section A and Section B in a statistic test. So there is a significant difference. So that means we can say that the two values are not equal with one another, because again, we state that there is a significant difference. So here, this one is two-tailed test. Now, why is this one two-tailed test? Because we just want to check if there's a difference between the two means of the sections. We don't want to identify which one did better compared to the other one. So that's why this one is a two-tailed. And another example, a researcher wants to know if there is a significant difference in the driving speed of male and female drivers. So let's state the null and alternative hypothesis. So here we are comparing the driving speed of male and female drivers. So again, for our null hypothesis, we just want to state that the two values are just equal with one another. So we will write there is no significant difference in the driving speed of male and female drivers. And if I want to write it in symbol, so the speed, so let's say the mean speed of the male is just equal with the speed of the female. And for our alternative hypothesis, so there is a significant difference in the driving speed of male and female drivers. So that means the two are not equal with one another. And lastly, a dietitian wants to confirm if the average weight loss of people who exercise 30 minutes per day for 6 weeks is greater than 3.7 kilograms. So here, we want to compare the average weight loss of the people who exercise with the hypothesized value, which is 3.7 kilograms. So again, for our null hypothesis, we want to state that there is no difference between our population parameter and our hypothesized value. So we will write the average weight loss of people who exercise 30 minutes per day for 6 weeks is 3.7 kilograms. So we will write here the average weight loss, so let's say like that one, is just equal with 3.7. And for our alternative hypothesis, so we want to say that there's a difference, and that difference is the average weight loss is greater than 3.7. So we just have to write it like this. The average weight loss of people who exercise 30 minutes per day for 6 weeks is greater than 3.7 kilogram. So here, greater than 3.7. So this one is again one-tailed test because as you can see, we use the word greater than. So that's it for today. I hope you learned something about the basic concepts of hypothesis testing, and see you next time.